So it is day 19 today, and we are starting Unit 2. Now, this paper has the wrong date on it, so I'm just going to change that on mine for the sake of this video. It is Wednesday, April 23rd. Okay. And we're going to be talking all about probability, and then we'll talk about systems of equations. But today we're going to mainly focus on probability. And hopefully my thought here is that this will feel like a little bit of a break, because the math and finding probability is a lot more simple. So on this handout I gave you all, I wanted you to try answering these questions below to the best of your knowledge. And if you were unsure, I just wanted you to make your best estimate or your best guess. And we are going to cover these right now. So for number 1, I asked you guys in your own words, what does probability measure? Do you guys have any thoughts about what probability might be measuring?
The chances of something happening.
Yeah, the chances of something happening. So it's kind of like if you think, like, what's the probability that it will rain today? You could put that as a percentage maybe. Like, oh, there's a 50% chance it would rain. I'm going to give you an actual definition for that for you to write down. And Chloe, your explanation was pretty much spot on. Let me grab a writing utensil. So probability measures how likely an event, such as rain happening, so how likely an event is to occur or happen. Usually we write probability as a fraction, a decimal, and finally a percentage. Okay. So we use probability to help us make an estimation about the chances that something might happen. So moving on to number 2, I wanted you guys to answer these true or false questions, writing T or F. And now we're talking about dependency. Now, if you're unsure about what a dependent event versus an independent event, I'm going to just trace over those. These came out a little light in the copy machine. If you were unsure about what those words meant, that might make these questions a little trickier to answer. So before we answer these, does anybody know the difference between those words, dependent versus independent?
Dependent means something that you're doing.
Something that you're doing, okay, versus independent. How do those compare to each other?
Independent is when the outcome, one event doesn't affect the other events.
Yeah, you guys are both getting it. So independent, I like to think of that I as being I, me, standing alone. If I am independent, I'm doing it myself, you know? So if an event is independent of something else, nothing is affecting it but that singular event. Dependent means it's going to depend on something else. Things are going to affect it. So independent, let's see. I think for that, we could write independent does not depend on another event. It stands alone. It's by itself. Versus a dependent event that is affected by other events. So I'm writing outcome is affected by other events. Okay. So the first true or false question I asked was, I guess not asked, it's a statement. We want to say if this is a true or false statement. A coin flip and a dice roll. So I flip a coin and then I roll a dice separately. These are dependent events. They affect each other. Is that true or false?
False.
False. If I flip a coin and I roll a dice, if I roll a 6, for example, does that mean I'm more likely to get a heads on the coin? No, they don't affect each other. They're completely independent. So this is false. The next event I've written is choosing a card from a deck. So if I've got a deck of 52 cards and I pull one out, and then I choose another card from the same deck without putting that first card back. I said that these are independent events. They don't affect the likelihood of each other. What do you think? Is that true or false? That's also false. It's also false. So let me grab, I have a deck of cards and I'll show you how that affects each other. Where's my card deck? It's actually right here. So I have some playing cards. And there are 52 of them here. So let's pretend they are all different. Let's pretend that there's not 4 of each kind and all of that good stuff. We're going to say I've got 52 totally different cards. So I have, for example, a 1 in 52 chance of picking one specific card. For example, this is what? The Queen of Spades. So I pulled this card out. How many cards are left? 51. Not putting this card back does affect how many cards are left now. Now to pull another card, there's a 1 in 51 chance rather than a 1 in 52. This did affect the outcome of the next event. So these are not independent of each other. Pulling one out and not putting it back makes these two events dependent. So moving those to the side, and we will get so much more into this later in our lesson. So if you're still a little like, I'm not totally sure what you're talking about, no need to worry yet. So these are both false here. Now moving on to number 3. Okay, I have a bag that contains 3 red blocks, and I have a bag that has 2 blue blocks. Now these blocks are all in the same bag. I asked if you draw one block and replace it, meaning I take a block out of the bag and then I put it back before I do another, what's the probability of drawing 2 blue blocks? What were your guesses? B, D, 20%, 1 out of 5. Any other guesses? C, 4 out of 25, 16%. Any other guesses? Or did everybody think maybe C or D? Okay, so I'm going to tell you now the answer is C, and we will explain why later on. For now, let's just have the answer written, and then we're going to explain here in a moment. Okay, so that answer is C. We'll discuss this more in a moment. Moving on to the back page. there's another question. I asked if a spinner is divided into 4 equal parts right here, and those parts are labeled A, B, C, and D. What is the probability of spinning A 2 times in a row? Anybody have any guesses?
Number 3, did you say the answer was C?
Yes, the answer was C for number 3, and I did not explain that yet. We'll talk about it here in a minute. So looking at number 4 now. Does anybody have any idea about how we would find this probability before I teach it to you? 2 out of 4? Could be. That's a good guess. I'm going to put that down. 2 out of 4. What were you thinking, Lisa? 1 out of 4? Okay, 1 out of 4, 2 out of 4.
Yeah, you just write like if you want A, so it's 1 out of 4, and you multiply it times the number of. So if you're spinning twice in a row, that'd be 1 out of 4 times 2. Or sorry, yeah, 1. I don't know how to say exactly what I'm thinking, but I'm pretty sure that if you got 1 out of 4, you do it twice, you multiply it. Yeah, so I think you get 1 out of 8.
So you have 1 out of 4 is the probability of spinning A, and then you want to see the probability of spinning it 2 times in a row. Are you saying we would add it to another 1 out of 4?
Yeah.
Okay, so that would give us that same 2 out of 4, or 1/2. Okay, so these are all good ideas, guys. These are good ideas. What if I told you the answer was actually 1 out of 16? What? Okay. Again, this is one that you're going to be thinking, what on earth? How'd you get that? We're going to talk about it. We're going to talk about it. So put this to the side. Hold your confusion. We're going to clear it all up here in a minute. Let's all get our notes out, and we're going to take some notes and learn the method to the madness. We're going to learn how to do this today. So we are starting a new unit today. This is unit 2. And if you like to section your notes in any particular way, I'm going to be starting kind of a new title here. So this is Algebra 2, Unit 2. And today is day 19, so I'm going to label this as our day 19 notes. And this is page 1. So we're going to start by titling this page with the word probability. That's what we are learning all about today. Probability. Probability. And you may have already written a definition on that Do Now handout paper, but I'm going to rewrite it on here just so it's in our notes. So once again, probability. Let's zoom in a little so y'all can see it better. Probability measures how likely an event is to occur. How likely an event is to occur. And again, we write that as a fraction or a decimal. or a percentage. And then we're going to talk about two different types of probability here. So under that definition, I'm going to draw a line straight across my paper. And for the remainder of my page, I'm going to leave it, don't worry. I'm going to draw a line that goes all the way down to the bottom, splitting my page in half. It's about here. And on the first section at the bottom, we will write independent events and on the right, I will write dependent events. And I know I'm giving you lots to write today, so I will pause in between to let you guys get it written down. I don't want to stress you out and rush you. So I'll pause our recording for a moment, let everybody get caught up to this point. Let's get some definitions for the difference between these two types of scenarios here. Independent events do not affect each other. Dependent events do affect each other. So whenever we're talking about two independent events, I'm going to give us, for example, that number 4 on the do now. When I spin my spinner one time and then I spin it again, no matter what I land on the first time, that's not going to affect the probability of what I could land on the second time around because I'm not changing the spinner. I'm doing the same process. Nothing has changed. It's the same probability. Here's how we would write something like this. And here's how we can kind of explain number 4. So if I want to know the probability of two events occurring, we're going to call one event A, and another will be event B. So I'm going to grab some colors so I can kind of separate these. I'm going to say the probability of two independent events both occurring would be written like this. For probability, we would start with a P. P for probability. And then I'm going to put a parenthesis here. The probability of event A, and that's just my and sign, event B, I'll use a separate color. So the probability of both of these happening is equal to the probability of event A times the probability of event B. So this is a new sort of notation. This is how we write probability. We're not thinking of P and A as variables like we normally would. I'm not doing P times A. This means the probability of A times the probability of B. So once we have that little formula written down, we're going to look back at that do now problem, number 4, and we're going to use this to figure out our probability. So I'm going to give everybody a minute. I see some of us still writing. Pause for a moment. All right, so I'm going to pull this do now out. And now I'm looking at this scenario where I've got this spinner, and it's divided into 4 sections. We're trying to figure out what's the probability of spinning A 2 times in a row. These are independent events. They don't affect each other. So here's what we'll do. First, I want to figure out the probability of landing on A. So looking at my spinner, how many options are there here on this spinner?
4.
There's 4 options. There's A, B, C, or D. So we're going to put 4 at the bottom. This will be our total number of outcomes possible. There's 4 possible outcomes. On the top, I'm going to talk about how many times is it possible to land on A if I just spin it once. So how many times is A listed on the spinner? Just once. So the probability of spinning an A is 1 out of 4 times. I want to know the probability of doing it twice. So we're going to say, what's the probability of spinning A again? Well, we just found out that the probability of spinning A is 1 over 4. It's still 1 over 4. So now I have these 2 events happening. They're the same event, but it is still 2 events. And now we're going to use that little formula I just gave you. A and B equals probability of A times probability of B. Don't let it confuse you that these are both A. If it helps, I'll make the other A purple. So I want to know now, what is the probability of spinning A and then spinning A again? So there's how we would write it. What is the probability of spinning A and then spinning A again? So looking at the 2 things we wrote above, what is the probability of spinning the green A? What did we write here? 1 out of 4. Okay, so we're going to do 1 over 4. And our formula tells us that we need to multiply that by the next event, which is spinning A again, 1 over 4. So I'm going to multiply by 1 over 4. Now, multiplying fractions looks really scary, but it's actually super easy. Here's how we do that. We're just going to multiply straight across. What is 1 times 1? 1. What is 4 times 4? 16. So, the probability of spinning A 2 times in a row is going to be 1 out of 16 times. Because if you think about it, if I spin A once, the next spin could be A, it could be B, it could be C, it could be D. There's about a million different possibilities for the 2 different events happening. For example, let's say I spin A first. I could spin A again. Let's say I spin A first. Maybe I could spin B second. I could spin A first. Maybe I spin C next. I spin A first. Maybe I could spin D next. Okay, so I've gone through all of the possibilities of spinning A first. What if I don't spin A first? I could spin B first, then A, B, then B, B, then C. You don't have to write this. I'm just going to show you where the 16 comes from. I could do B, then D. Okay? What if I spin C first, then A, C, then B, C, then C, C, then D. And then finally I could spin D first, then A, D, then B, D, then C, D, then D. And let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 possible outcomes here. Only one of them did I spin A twice in a row. You see that? This is the shortcut. That way you don't have to write all the possibilities out. We just multiply those 2 probabilities, we get 1 over 16. I think it's kind of neat, but you know, everybody's got opinions. So let's go back to our notes. And on our independent events, I want to have us write just one more little example so that we can have something to look back at all in one area. So here is an example. 2 independent events. I'm going to say, if I flip a coin, this would be event A. And I roll a die. Whenever I say roll a die, I'm talking about one of these dice. That's just the singular. One dice would be called a die. So if I flip a coin and I roll a die, rolling the dice will be event B. Here's how we find the probability, for example. Of flipping heads on the coin and rolling a 6 on the dice. So heads and rolling a 6. Now we need to know how dice work for this to make sense. So here's the interactive part. I'm gonna give you all a dice. I'm gonna pass this out while I pause this. So now that I've passed all those dice out, let's look at it. How many sides are on this die? Oh, there's 6. Let's count. 1, 2, let me find the 3. 3, 4, 5, 6. There are 6 sides. So first, let's think about how many possible outcomes would there be for rolling a dice? How many options are there? 6. There's 6 sides. So rolling a die, we're going to call that the event B. So probability of, I used green for that. I'm going to say rolling a 6. Probability of rolling 6. That's how we write it. The number of outcomes goes on the bottom. And we said that there are 6 sides. There's 6 possible numbers we could land on. So the number at the bottom will be 6. We want to know the probability of just rolling the number 6. Now, how many times do we see 6 dots on the die? Just once. So the probability of rolling a 6 is just 1 out of 6. Now, the other probability we need to look at is flipping a coin. So I don't think I have enough money to give everybody a coin, but I think I have one in my purse. So here's a quarter. This side is my heads. This side is what we call tails. How many sides does that coin have? 2. So how many possible outcomes are there with the coin? Just 2. So I'm going to write below that. I know I wrote the die first. I should put that above. So the probability of heads is what we're going to find. So we said there's 2 sides. So that would be our total number. How many times do you see heads on the coin? Just once. So the probability of landing on heads is 1 out of 2. The probability of rolling a 6 is 1 out of 6. How could we find the probability of both of these happening? We're going to multiply them, absolutely. So I'm going to write the probability of heads and I'm just going to write 6 instead of rolling 6. I don't want to run out of room. Probability of heads and 6 is, well, the probability of heads is 1/2. And the probability of 6 is 1/6. So we're going to multiply 1/2 times 1/6. And again, all we do is multiply straight across. What is 1 times 1? 1. What is 2 times 6? 12. So what's the probability of both of these happening? 1/12. There it is. We found probability. Kind of cool. Now, one last step and then I'll let you have a break. It's getting late. I'm going to also show you real quick how we make this into a decimal and a percentage. Super, super easy. Everybody just use your calculator. Remember, a fraction is just a division problem. 1/12 means 1 divided by 12. So all I need to do is type in my calculator 1 divided by 12. And I get, 0.083 repeating. So I'm going to write 1/12 equals 0.083. And that 3 is repeating, so I'm going to put a line over it. Now, does anybody know, I've never taught you this, but does anyone just know how I turn a decimal into a percentage?
You move the decimal over 2 spaces.
Yes. You just take this decimal right here. See your point? There's a 0.83. We just move it over 1, 2 spaces. So I go from 0.083 to now, since I moved it after the 8, for my percentage, I will have 8.3 repeating percent.
Will you always only move it 2 spaces?
Yes, that will never change. To change a decimal to a percent, you just move the decimal 2 spaces to the right every time. So the probability of heads and 6 happening is 8.3%. Kind of neat. You can do this for anything. So there's our first example. We'll do some more notes later. I think we are ready for a break. It is 10:37. We'll say it's 10:40. Let's just come back around 11. Okay, so I'll put up a little sticky note to remind us, come back around 11, and you guys enjoy your break. So we're back from our break. Let's go ahead and finish our notes. We've gotten some on independent events, and now let's move over to dependent events. So we just talked about finding the probability of 2 events occurring that are not going to affect each other. But now there may be times where events do affect each other. For example, let's say, well, before I give you that example, I'm actually going to write out the formula for that. So the probability of 2 dependent events would be the probability of, let's write A and B. Okay. This will be a little different. Now we're going to look at the probability of A, and we're going to multiply by the probability of B with a line next to it, given A. What does that mean? I'm going to tell you here in just a second. Let's just get that written. And under it, so we don't forget what that means, how we say it, I'm going to write, this is the probability of B given A. We're saying that we need to find the probability of the second thing happening, given the fact that the first thing, A, has already happened. So I'm going to put a bunch of different colors of dice up on the screen to kind of give an example of that. Okay. So how many dice do I have here total? 7. I've got 7 dice. So let me get a little sticky note. I have 7 dice total. And I've got a few different colors of dice. I've got 2 that are orange, so I'm going to write that. 2 orange. I have 1 pink. It might look red to you. So 1 pink, 1 purple, 1 green, and 2 blue. Okay, so I'm going to move these out of the way, and I'll keep this up here where you can see it, but I'm going to flip my page so that we can write out the work for this example. There we go. And here are my dice. So let's say that event A is picking an orange die. So picking an orange. So first of all, here's all my dice. What is the probability of picking an orange die? 2 out of 7, absolutely. So let's write here the probability of A is 2 out of 7. Now, how did we get 2 out of 7 for our probability? Yeah, there's 2 orange die, and there are 7 dice total. Absolutely. So we've got that. Probability of picking an orange the first time is 2 out of 7. So let's now say we picked the orange and we don't put it back. How many dice are left now? Now there's 6 left. So when we say B given A, what I'm going to write next, I'm saying A already happened and we didn't put it back. This will affect the outcome of the next event because now we don't have 7 total anymore. Now we have 6 total. So let's say that event B given A would be picking a purple die. Picking a purple. So, given the fact that we already took the orange out, we only have 6 dice left. How many purple do we have left? 1. So the probability of picking a purple one, given that we already picked an orange and we didn't put it back, is going to be 1 out of 6 because there's only 6 left and there's only 1 chance of getting a purple out of those 6 dice remaining. So using this probability that we've come up with here, I want to see in total, what is the probability of both of these happening? What's the probability that I pick an orange the first time and then after I don't put the orange back, also picking a purple? So we're going to look back at that formula that we wrote here, the probability of both happening. So we have the probability of A and B equals. So we need the probability of A times the probability of B given A. What's the probability of A? 2/7, 2 out of 7. So I need to do 2 out of 7 times, what's the probability of B given A? 1/6. And finally, all we need to do now is multiply straight across. So what is 2 times 1? 2. What is 7 times 6? 42.
Now, could you simplify?
You can simplify. What would this simplify to?
1/21.
Yes, I could divide 2 by 2 to get 1. 42 divided by 2 to get 21. And this would be my probability as a fraction. 1 out of 21. Now, if I want to make it into a decimal, how do I do that? Divide. 1 divided by 21. So go ahead and do that. And when you get a decimal, let me know what it is. 1 divided by 21. What do we get? Perfect. 0.047. There's more. 47619. It goes on for a while. I'm just going to put this for now. How would I write this as a percentage? 4.7. I take my decimal, I move it over 1, 2. The new decimal place goes after the 4. 4.7%. That's a pretty low chance of both of these happening. Only 4% of the time will it happen. So these would be our 3 different ways to write the probability. 4.7%. So using this same number of dice, let's find another probability just to get a little more practice in. Let's say now event A, I think I'm going to make my events match the color because that's a little confusing trying to decipher the two. Let's say event A is picking a blue dice. And let's say, grab another color here. Let's say B given A. Is picking a green after picking a blue. So first of all, first and foremost, what would the probability of event A occurring be? How do I find this probability? How do I find this?
There's 7 dice and there's 2 blue ones, so it'll be 2 out of 7.
Perfect. There's 7 dice total. That'll be my number on the bottom. There's 2 blue dice. That'll be the number on top. So the probability of picking a blue will be 2 out of 7. Perfect. Perfect, perfect. Now we need to figure out the probability of event B happening given that A already occurred. So let's write this. Probability of B given A. How would I find this?
There's one green, and we've only got. Yeah, let's put that over.
And how many do we have left now instead of 7?
Blue away?
After taking the one blue one blue die out. 6. Good. So the probability of picking a blue first is 2 out of 7. After we take that blue out and don't put it back, the probability of picking a green is 1 out of 6. Well, we accidentally did the same problem. With the same numbers as before. So we already know the answer. We just did it. How about let's pretend that there are 2 greens, just for fun. Let's pretend there's 2. Let's just pretend so we get a different number. Okay, so how do I find the probability of both of these happening? You just multiply them. So let's do that. Probability of A and B equals 2 over 7 times 2 over 6. So multiplying straight across, 2 times 2 is 4. 7 times 6 is 42. We could simplify. What would this simplify to? 2 over 21. So I'm just dividing them both by 2. We get 2 over 21. All right, so now that we have our fraction, I want to see if you guys can get your decimal and your percentage next. 2 over 21. Let's find the decimal and the percentage. So I'm going to find that over here myself. I'll give you guys a minute to try to do that on your own. Right. What's our decimal? 0.095. What's our percentage? 9.5%. Good. Very, very good. Okay. Okay. So let me give you one more scenario. I want you to try this one on your own. I'm going to draw a picture for this one. Completely on your own. Let's say I have a bag full of marbles. Okay, and in that bag there are 1, 2, 3 that are orange, and 2 that are green. 1, 2, 3, 4, 5 that are blue. So I'll just list those out. 5 blue, 3 orange, 2 green. So first, I want to know, what is the probability of picking an orange? Once you find that, I want to see if we can solve for the probability of picking a blue marble, given that we already picked an orange. Okay. So hard to see the colors on here. This is helping you guys see a little better. I feel like it was kind of dark. Is that better or worse visually? It looks better. Okay, good. All right, I'm going to give you guys a few minutes to try that on your own, and then we'll look at it together. So, what is the probability of drawing an orange marble?
3 out of 10.
Yes, 3 out of 10. There are 10 marbles total, and there's 3 orange. So, there's 3 chances to get an orange marble. That would also be 30%, although we just need the fraction for now, so that's good. Okay. So now, given the fact that we drew an orange one already, the orange is gone, we took 1 marble out. What is now the probability of drawing a blue marble?
You put it back or give it out?
We kept it out. We didn't put it back. 5 out of 9. Perfect. There's 9 left, and there's 5 blue. So, how would we find the probability of both of these happening? What would I do?
Multiply them.
Just multiply them. 3 out of 10 times 5 out of 9. So 3 times 5 is 15. 10 times 9 is 90. We could simplify this, but let's go ahead and find the decimal. So 15 divided by 90, what do we get?
0.116.
Perfect. 0.16. Repeating. What's the percentage? 16%. Now, if you wanted to get real technical, since that 6 repeats, we could say 16.6%, but I would just take 16 the same. That is just fine. Perfect. Both of them are correct. I will take either one. So there's our probability. Okay. Not too bad. Not too bad. All right. So the way that you would see this written and the way that I will have it written here on this exit ticket, I'll explain it to you guys real quick. This is what your exit ticket will be. It's another marble problem. I've got a bag with 4 orange marbles, 5 green marbles, and 1 purple marble. My question says, what is the probability of drawing a purple marble? So you'll find that first. Then an orange marble without replacement. When I say without replacement, that means we did not put the marble back after the first one came out, right? So before I send you off to try this, let's talk about what our thought process will be to doing this. How would I start this problem? What would I need to do first?
That's the first event.
My first event. So I need to find the probability of drawing a purple marble. So I'm going to write that out for us. The probability of drawing a purple marble. What would I do next?
Second event.
My second event. I want to know the probability of drawing an orange marble, given that I already did a purple. So, orange given that purple already happened. And finally, what would you do at the end to find the overall probability of both happening? You would multiply those two fractions and get your decimal, your percent. So I've started it for you. Here's our steps. I have the exit ticket for you up at the front of the room. So feel free to grab a copy of that. This will be due on Friday, and once you finish, you are free to go. That is all for today. Okay, and I'll go ahead and end this real quick.